Hi, we'd like to welcome you to another in a series of webinars designed for public transit agencies. And I'm Terry Bills, and I'm the Transportation Industry Manager here at Esri. And today I have the great pleasure of hosting Rodney Bunner of Service Edge Solutions to talk about how the TBEST model can support more effective transit route planning and service design. Before we begin, I'd like to point out that we are recording this webinar, and while everyone will be on mute, there will be time for question and answers at the end of the presentation. So you can type your questions into the question box, and we'll try to answer as many as time allows. And additionally, the slides that will be part of the presentation today will be made available to you on the GeoNet group, Departments of Transportation, and we'll give you the link to that at the end of the webinar. So let me start by stating that solving our mobility issues is probably the central challenge for, let's go back, for most cities around the world. And rapidly increasing levels of congestion, which limit accessibility and which contribute to our air quality issues and generally degrade the overall quality of life in our cities. And ultimately, this is not sustainable for the future. So I think it becomes a given that you cannot be a smart city without solving your mobility issues. And I think that is true worldwide and remains one of our greatest challenges. So I think most transportation professionals would agree that public transit really has to provide the backbone and the core elements of any city's transportation solutions. And that said, the mobility patterns of our urban areas are rapidly changing, and the way that people want to travel and navigate through, whoops, why is this jumping around? There we go, sorry, that's together with the diversity of our urban populations and really the expectations of a new generation is all changing. And so I think what that really means is that transit agencies are going to have to think differently about the types of services that they provide and how they think about facilitating greater mobility in our cities. And I think that will require tapping into a wide range of new data sources to help understand those changing mobility patterns and how we're going to have to better understand and better coordinate across the different modes. And unfortunately, it's still the case that we often have different agencies responsible for different elements of our transportation systems. And we need to think and coordinate more holistically. For ultimately, we're really talking about the livability and the sustainability of our cities. And this may ultimately mean that we need to rethink how we not only design and build, but also redesign our cities for the future. And in terms of the subject today, more effective route and service planning, that's really the immediate challenge for most transit agencies. And I think most transit agencies would also agree that these three key metrics are central to providing, oops, not sure why this is jumping around, are providing the core basic services. So with that, let me turn it over to Rodney, and Rodney, let you take it away there.
Okay. Well, thanks, Terry, and thanks to Esri for inviting me to present, and for everyone taking the time to listen in and hopefully learn a little bit about TBEST. So the approach to my presentation is going to be to go through some slides so you have some context as to the history of TBEST and applications and utilization of TBEST, and then run through a demonstration so that you have some real world application experience with it. All right, so the development team has been, over the last 16 years, the public sponsor is Florida Department of Transportation, and we've been working together for that full amount of time, together with the Center for Urban Transportation Research at the University of South Florida, who has participated primarily in research-based methodologies, such as the model construct, accessibility measures. And on the software side, Service Ed Solutions has been the primary developer in terms of the software and also implementing at agencies around the country and providing technical support. So first question, of course, is what is TBEST? Software tool that provides transit data analytics and insights to support service planning and strategic planning initiatives at a transit agency or an MPO, or even, you know, on a per study basis. So some of the core features of TBEST, which we'll go into in great detail throughout the presentation, transit demand estimation. So what that means is ridership forecasting out into the future, market analysis, transit operational analysis, equity, accessibility, and jurisdictional analysis. So all of those are part of it, all of this wrapped around the GIS features and the modeling features within TBEST. And I mentioned the FDOT manages TBEST. They also provide data products for the whole state of Florida. So they support all of, in terms of technical support and data products for Florida. If you're outside of Florida, you're obviously welcome to utilize TBEST. It's a free software download you can get to on the TBEST website at tbest.org. And we'll talk a little bit more about how you would use it outside of Florida. So why do we need TBEST? Well, if you look at transit in terms of, you know, really three stages: operations, short and midterm, and long range. Clearly, the operations side is handled in-house with Trapeze and Hastis and other softwares. And long range, you have, you know, Cube Voyager, Transcad, STOPS model to handle long range estimations. But in the short kind of 0 to 10 year time frame, there's been a gap in softwares that have been able to produce ridership forecasts and accurate market analysis for the agency. So some of the objectives in TBEST are to provide data integration for national, regional, and local data. So we're not fully reliant on just national data sources. Certainly you can bring in regional data from your MPO, such as TAZ data, obviously local data sets in terms of the GTFS and any local conditions you might have. We also integrate agency policies. So whether it's Title VI or operating conditions, all those can be input and managed within TBEST. And we have a transit focus. It addresses transit-specific planning issues. What TBEST is not is a multimodal tool. It's only a transit tool. So because we do that, we can get very detailed into the transit level of service and some of the details in terms of costing of transit. We also have scenario planning. So really what we want to do in terms of, you know, if we're planning out into the future, is create alternatives to the current network. And TBEST provides a whole set of tools to create new routes and modify routes, new service, socioeconomic conditions out into the future. Number 5 is efficiency. So consistent, streamlined, and repeatable analysis workflows. And this actually comes into play a lot with something that happens in the industry a good bit with agency, is that there's employee turnover. And so when the next person comes in, it's a little bit difficult for them to repeat the processes that their predecessor was up to. So, so this is a way to kind of encapsulate and create repeatable workflows for analysis. And of course, communication, we want to inform the decision makers with lots of maps and tables and charts and numbers that are critical for making the decision in terms of whether routes should go forward, or even larger context mobility decisions. And finally, cost effective. It is a free software. Documentation, training videos are provided, and you can use it as an internal agency tool set. So you can share it among your many staffers in terms of your planners and other folks, and use it together as an internal tool set. So what can TBEST help you support? Transit development plans. This was the primary goal when we first started developing this 16 years ago, was to support TDPs. But it has moved off into other studies and application types that you can see here: route optimization studies, operational analysis, regional modeling and planning, specifically BRT modeling, Title VI, triennial reporting, disparate analysis, grant applications, corridor analysis, and there are many more applications for TBEST. So in terms of the technology that you'll need, number one is that TBEST is its own standalone desktop software, but it does have embedded Esri technology. Specifically, it requires ArcGIS to be installed at the basic license level on your machine. It's compatible with 10.2 to 10.6.1. Just a note that 10.6, while it will work, there are a few things that don't quite work right. So if you're at the 10.6 level, you should go to 10.6.1 in order to fully operate TBEST. It'll also install SQL Server Local DB, and Visual Studio Express is optional. It doesn't install with TBEST, but if you want to do any kind of model scripting, you'll need Visual Studio Express. All right, so the primary integration that we need is with a network, right? So agencies maintain their networks via their operational softwares, and generally they will output into a GTFS format. So TBEST makes and takes advantage of that through our GTFS network import tool. So what this does is you select a particular service day for a weekday, Saturday, and Sunday, and select the routes that you would like to come in, and TBEST will bring those into a scenario, a TBEST scenario. And that could be a base year definition in terms of the routes or the GTFS, but it could also be a proposed service, right? So it's not limited to base year integration. It can be the future year as well. So once you have that, you bring it into TBEST with minimal review. You're ready to do modeling analysis, service evaluation, and all the tools that TBEST has. So one note about this is that APC, automatic passenger count data, is available to be brought in through an additional file, a TBEST file specifically called stop.ridership.txt. So if you format this file, populate it, add it to your GTFS, TBEST will bring in your APC data, your stop level data, and utilize it within the software. So this is our own format. However, there is a new GTFS schema that's kind of being looked at right now called GTFS Ride. We're also looking at that for potential compatibility going forward. All right, so once you have your network into TBEST, then you want to edit it, right? So you want to be able to add, edit, remove routes, individual route patterns, modify segments, remove and add stops. So anything that you would want to do with a transit network, including inter-vehicle trips and travel times, assign stop amenities and special generators and identify transfer stations, all that can be completed within the TBEST network editor, and we'll go through that in part of the demonstration. So all this is within an ArcGIS-based map editor, so it's not actually operating within ArcMap, it just uses some of the components of it. And the base map is configurable, so you can use ArcGIS Online maps, there's a whole selection of them, or you can use your own MXD locally that you have as a base map. And what's important here is that you can export whatever you develop in terms of a transit network out to GTFS, or into shape files, or into KMZ, or into a file geodatabase format. And the GTFS obviously is important because you can then share your full network with other applications that might be using it for other needs. The shape files and KMZ are more for your ArcGIS Online to upload directly into a web map. All right, so all of the network sits on top of socioeconomic data. And I mentioned before that we don't just go with the national data sources. We allow you to configure what you want at the local level so you have the most accurate representation of your conditions. So we generally use Census 2010 data for at the block level, and then we update that with American Community Survey 5-year data. So we're currently at the 2017 level for American Community Survey. So that's our basic demographics. And then at the employment level, we can use really 3 different data sources, the LEHD, which is again a census product, but you can also use zonal or TAZ, Transportation Analysis Zone data that the MPO might manage, and you can bring that into TBEST and use it as your employment source, or address-based or point level data, and that could come from a commercial vendor such as InfoUSA, or it could come from your parcel data. You might actually manage some employment data within your parcels, and you can use that as an employment source as well. The third item on the list is parcel land use data. So this is an optional input, but really one that's very important, because what we do is we generate person trips or activity levels, trip activity levels at each parcel. So we're able to use IT trip generation rates, calculate the number of person trips by time of day, and then use that in our market analysis within the model structure as a very fine-grained data input for you to use for analysis. And all of that pushes over to the right where you have your MPO growth projections, because we're not estimating ridership based on the conditions that are going on right now. We want to push that out into the future. So the growth projections that the MPO has, that's just an input to TBEST, and it will grow your socioeconomic data out based on the forecast years and the zonal growth rates within the TAZs. All right, so one item in addition is that we have a parcel editor. So again, this is a GIS-based parcel editor, and the parcels within TBEST are points. They're centroids for the parcels, so they're a little easier to work with than polygons. And so you can add them, you can move them, delete them, and really this is for if you have a brand new development that's coming on, or you're changing the land use mix drastically, especially as it relates to transit, such as a TOD type of development. So you can completely change the land use mix around your transit. You can also auto-generate parcels. So if you know the number of parcels by land use type and the number of total building square footage you're going to implement, then you can actually generate randomly the parcel locations within an area. So that gives you the density that you wish to have. Maybe it's not as accurate in terms of exactly where they will be, but then again, you may not know where they will be in the future. So, just so you know, the parcel editor is there as well. So another key component is estimating ridership. So we talked about this as one of the core features of TBEST, and it actually estimates ridership at the stop level. So for every stop in the network, and it actually does it for by time of day. So there's different models for AM peak, off peak, PM peak, night, and then separate models for Saturday and Sunday. So in total, there are 6 models that run when you run a TBEST model. In addition to that, you get both direct and transfer boardings estimations out of that. So it's not just a one number. It will tell you the kind of transfer rate that you have in terms of ridership at each stop. So it responds to service level adjustments, route restructuring, fare changes, transfers, walk markets, destination markets, and also BRT characteristics. So we'll talk a little bit more about that later, but you can actually score the BRT in terms of implementation levels of different characteristics. You also have validation tools. So whatever you estimate in terms of the model, you want to make sure it's validated to the local context. So we have tools that allow you to do that. So when you apply TBEST out into the future, it will adjust based on the context of your local performance. All right, so once you've estimated ridership, you want to evaluate performance and service. So we have a comparison tools. We have lots of comparison tools that put the base condition against a scenario alternative so that you can see at the route level or at the system level how your new alternative or your new network is performing. And that includes like a performance measure such as boardings per service mile, per service hour, or per service trip. So you can see route costs associated with the implementation and also the estimates of your fleet that will be required. So all of that is put together so that you can really determine the delta for any variable that TBEST carries, and then make your decision about how to implement the routes from there. And it becomes more of an iterative process at that point to kind of refine your routes and maybe reposition stops, et cetera, to make a more effective route. All right, you also want to look at markets. So if you've designed a route, you want to look at and quantify, what is the land use around it, what is the demographics around it. So we have a market analysis tool that will do that, and you can do it around stops and segments and route patterns and any user geography that you wish. We can summarize what's inside of it in terms of land use and demographics. So you can easily compare across scenarios as well. So it's a really kind of a unique tool to do that. In addition to just walk market access, you have network accessible. So for any one stop or multiple stops within the system, you can determine the destination accessibility through the transit network to attractions. So those would be population, employment, land use types. You can break that down in any number of ways, including by transfer, right? So how many transfers does it take to get to a destination from a given point, right, or multiple points? And the components of that are not just in-vehicle time, they're also walk time, number of transfers, transfer wait time, et cetera. And you control how TBEST summarizes that and implements that through an interface. All right, so there are actually 5 different workflow support tools, and I'm showing this because we're not going to get to all of them. They're very useful, but we only have so much time here, so I want to just introduce them in terms of what they perform for you. So they're really meant to streamline tasks, right? Common agency tasks, and you input a scenario and then some parameters and that are specific to that task. And you can run through multiple analysis and it creates results sets. And then you, in the end, you compare the result sets, and we also have dashboards for some of them, and consoles and reports and maps and charts that support all of this. So this is your analytical tools that you basically, they're all wizard driven, and you run through the wizards, create the result sets, and then we have the tools to compare the results. All right, so this is an example. This is our CoA Analysis tool set, and what it does is it uses both the observed ridership that you might have that you brought in from the GTFS, I mentioned that earlier, and whatever TBEST might estimate as well in terms of ridership. And there are 2 basic functions of this, and number 1 is a density. So socioeconomic density, it's going to divide up your route by route, your service within low, medium, and high densities along that route, and then tell your performance and your service levels, et cetera, within each density level. And you can control the density levels and how they're set up so that you can then say, well, all the routes that are operating in high density population and high density employment areas have certain performance levels, right? So, so it allows you to kind of tweak that and play with it so you can do some diagnostics on density analysis with service and performance. We also have a jurisdictional analysis, so you input a shapefile or any user file such as rural or non-rural, taxable areas, municipalities, and TBEST will summarize your route service, again, your performance and ridership within those areas. So the example here is that we have jurisdictions, right? So Big Bend, Brandon, the Brandon Mall area. So these are all areas in the Tampa area that we're summarizing individually the routes that pass through them, the service that is for each route and in total for the jurisdiction, and the performance level in that jurisdiction. And it can be any geography that you input, you define the geography, TBEST will process that out and give you the reporting that tells you their performance in each one. All right, so equity is another big issue and workflow that a lot of agencies are required to do by the FTA. And so what we try to do is mimic as best we can the FTA circular for providing guidance for mapping and reporting specifically for triennial reporting, but also for disparate. And we have 2 tools. One is more for triennial, one is more for disparate. And we also incorporate a lot of the local context. So every agency will have a unique policy as it relates to Title VI, and we try to integrate their policies so that whenever we produce reports and maps, it's reflective of their policy. So a few of the items that this workflow will do is calculate the system percentage, disadvantaged populations, minority, low-income, LEP. It calculates minority and low-income routes, which if you do that alone is a very time-consuming process, and minority and low-income revenue miles and stop arrivals and several other. And in the end, you can compare them, right? So it's not just you're doing this for one scenario. You can do it for multiples and then compare the results. So that's another item that's very important. So The second is disparate analysis. So this is when you have a service change that would be over a 20% service change, and you need to make sure that you're doing it equitably in terms of minority and low-income populations. So this dashboard that you're seeing will allow you to input 2 scenarios. It will compare them and tell you if they're meeting your criteria in terms of the percent change that is your threshold for Title VI. And so you can see the check marks and then total annual impact for minority and low-income households. And if you have your check mark beside your annual impact, that means you're good. If you have a caution, then you might want to go back and look at it and do some reconfiguring of your network to make it more equitable. With this, if I think you can see my cursor, but there's a route detail button on each one of these. So if you click that, you can get to the specific details of every route. So is there a disparate impact at the route level? So this is also important. You know, you can do it at the system level, but sometimes you need to do it at the route level as well to see which routes are giving you a problem, right? So this is a way to do that. All right, and then we have accessibility, right? So system accessibility workflow support tools. We have a couple of different dashboards for this. Walk access, which is just straight walk access from transit to destinations. And then you have network access, which is more of the synthesis of your network in terms of trips. So from every stop to every other stop for an average trip, what percentage of the jobs and people can you get to in the network? All right, so this is something that's been constructed. You have a dashboard for it. You also have a comparative analysis for this, so that, you know, if you reconstruct a new network, you want to know, did I improve accessibility? Then that's something you can measure with this in TBEST. So, so I'm just introducing these to you. There's a lot that we can cover with these, but I just want to make sure you know that they're there. All right, so an example TBEST implementation, I'm going to pick on Lynx in Orlando. They maintain an active, validated TBEST model for their service and strategic planners. They have developed unique tools actually to help them within TBEST to measure additional trips related to some localized development. They developed a grant application for Sunrail, which is their new commuter rail service using the TBEST ridership estimation. They're supporting TDP, CoA, and currently a route optimization study using TBEST. And finally, their Title VI reporting policy includes TBEST as the methodology and output. So they're really utilizing TBEST for their complete service planning and strategic planning to the breadth of their ability. Other agencies using TBEST, most Florida agencies do, whether it's on a per project basis or in-house like Lynx, it varies. Nashville, UTA, and Salt Lake, Foothill Transit, that was more of a, you know, kind of a single project. RVTD in Medford is currently using it for a master planning study. GRTC in Richmond, and PART and Bend. So you can see there are many others that have that utilize TBEST and really have grown TBEST because all of what they do benefits TBEST in general. So so that's the good part. All right, so if you're an agency and you're looking at, okay, you've just told me all these things, what I need to do to install and utilize TBEST. Okay, so if you're either inside or outside of Florida, you have to have an install. So you download TBEST from the TBEST website that matches your ArcGIS version, and you install it on any number of machines. It doesn't matter. You're only limited by ArcGIS licensing. So it will use a license whenever you run TBEST. If you're outside of Florida, you need to configure the socioeconomic data. So FDOT provides guidance in terms of documentation and templates to configure all the data that we talked about, the SE data, national, state, regional, and local, so that you can create your own transit system with the data that you want underneath of it and go forward. All right, so number 3 is really validation, and that's developing your base transit service and SE conditions, and then running the TBEST model, and then using your observed ridership to match it up. So you're going to need your observed ridership at the route level to validate the TBEST model for your area. And then number 4 is application. So this is where your planners go out and use it on a project basis or service planning, et cetera, to create new alternatives to service and then support that with maps and charts and reports for various applications, right? And then finally, sharing. So the TBEST data products, and we're going to show you this a little bit, is all exportable, whether it's GTFS or ArcGIS or ArcGIS Online. You can use the data products in a variety of ways. All right, so here are some of the resources. So this is the TBEST website, tbest.org. You can download software, the user guide, video tutorials, the SE data configuration guidance and templates, and the technical assistance contact information are all available on the website. That's my contact information. So I'm going to switch over and run through some TBEST demonstration. So I'm going to bring this over. And so this is the basic interface. I had it open, so I didn't launch it. But so what I want to do is just kind of run through a few, whether it's a service evaluation, maybe some accessibility, and just some network editing tools that are within TBEST. So we'll start with the fact that in the TBEST Explorer window, you have 5 nodes. The first node that I want to talk about is SE data. So these nodes are data that are resident on my machine that are for various areas of the country where the SE data has been configured in various methods, right? So what I want to show you is that for Florida 2019, if you right-click on it, you can create a new transit system from this data. So this is the starting point. You have to have your data configured in order to create a new transit system and then start building scenarios, et cetera. But if we look at this in terms of the properties, you can see that it will tell you that the employment type is block level LEHD data. That year is 2015, the census is 2017, and the parcel year is 2018. So we have parcel data in here, and it's from last year, right? So that's good. And we have all the counties in Florida configured. So wherever you're at in Florida, you have the data to support your application. All right. So once we have that, we can create a transit system. So I'll go under the transit systems node, and we have several systems that have been configured throughout, whether it's Florida or nationally, that I have resident here on my machine. So any one of these, we can start by talking a little bit about the policy settings, right? So I mentioned that earlier. We tried to embed policy settings into TBEST, and this is generally how we do it, is to be able to enter this information and have it proliferate through all that you do within this transit system. So number 1 would be a service area, and this is really kind of something that varies. People define service area in any number of ways, including by county, but they can also do it by unique geography. So within TBEST, you have the ability to do either, right? So you can say whatever counties would be defining this particular transit system, you can select them, or you can select an area. In this case, there's none defined, so it's grayed out. But if you have a distinct shape, you can define your service area in that way. You also have a default operating cost. So in this case, it's $80 an hour, but you can have a split cost as well, or just by mile. It's up to you and however you manage. But this is the default cost. So whenever you create a new route, it will get this number. You can override this number at the route level, just so you know. Default layover and vehicle parameters. So a minimum percent layover time. So generally when you're planning routes, from a planning perspective, you want to have a percent layover time that you're going to bake into your schedule. So this is your kind of preset layover, and it may vary by route and by time of day, but this is what is a kind of a preset number. Again, you can override that at the route level if you need to. Vehicle capacity in terms of seats. And then you have your Title VI. So these are your thresholds, and this is your poverty levels. And generally this comes from the Department of Health and Human Services, but you can also override this with local data. So if you know your poverty level income doesn't really line up with the DHHS numbers, you can override it here. You have walk market capture distance, disparate impact threshold, poverty percent property income percent increase are all captured here as well as annual service days. So if you're going to annualize any of your summaries, you want to do it by weekday, Saturday, and Sunday. And of course, whenever you're talking about transit, you're talking about operations in terms of when do you have service. So some days you may not have service, so such as Christmas, you may not operate. And on holidays, you operate a Sunday service. So it's not a straight weekday has 255, it could be other numbers. So generally, this is what where you would input that number in terms of how many days you're active based on your schedules. All right, so now you know that, and that's a really good context for this. So what I want to do is I want to drill into the RTS system a little bit, and we've already created a few scenarios, and I'll just expand this one a little bit. So you can see that it's validated. So this little check mark means that it's validated for 2018. If I get the properties for the system itself, you can see that it's going to tell me the data that's associated with it in terms of the SE data. It's for 2019, and it's just Alachua County is the extent that we brought in. You can also add your image file. So this will proliferate through again, and anything that we open and do will have your logo on it. All right, so let's look at the scenario. So the first scenario is our validated base year. So it will always be, I have this little check mark by it, and it'll say base and read only if you have a validated system. And then you can have any number of application scenarios that you wish, right? So what we want to do is for our application, what we're going to look at right now, we're going to copy this base scenario. So we just go to copy, and we're just going to create a new scenario, and we're going to call it, I'm going to copy and paste here so I don't have to type and flub that up. So we're going to call it BRT Alternative 1 at Campus BRT. So this is RTS is in Gainesville, in case you didn't know. So Gainesville, Florida. And so we're going to set the forecast year to be 2018 because we're looking at this in terms of implementation, right now, right? Even though it's valid, it should be 2019. We're going to keep it at 2018 just for our demo purposes. And the rest of it is fine. We're going to have a mean annual wage will be the same. We're going to use the LEHD data and the parcel data, our default parcel data for this scenario. So we're just going to copy it. All right, so now we have our new scenario. And if we right click on it, we have several options. We can go to the network editor. We have a scenario summary tool, which we'll cover later. You can specify unique growth rates for this scenario, right? So on a scenario basis, you say, this is how I want to grow the population and employment. You can implement fare levels. You can do the network properties, and this would be kind of transfer stations. There's validation tools. This is how you would run the model. So you would run the forecasting model from here. You can get to the workflow support tools from here. So I mentioned those earlier in terms of Title VI and CoA and access to transit. And you can also get to your GTFS tools. So if you're going to import routes from a GTFS, you would do it from here or export this network to a GTFS. You can also export directly out into a GIS format. You can also import routes from other scenarios. So this is kind of a catch-all. So if you can build scenarios that are kind of holder scenarios for lots of routes, they're not really modeling, but they're just holding all the different route alternatives that you might want, and then you want to configure them into specific scenarios for modeling. So this allows you to transfer routes between TBEST scenarios for that purpose. All right, so I wanted to explain some of those just scenario-based options, but what we want to do is open the network editor. All right, so this will open, and once it's ready to go, I'm going to go ahead and pin this to the side so we have a little more real estate to deal with. And I'm going to bring this out so we can see some of a little bit more information about every route. So basically the route structure is here, the route list is on the right. And if we scroll over, we have a description, the type, whether it's a radial, crosstown, express type bus, the technology. We have just bus mode here, but we can also have rail in terms of commuter rail, light rail, heavy rail, and other modes, right? and some of the other route level specifics that we can set are here as well in this list, right? All right, so number one thing that you might do is select a route. So here's Route 11, right? Okay, great. I see exactly where Route 11 is here, and Route 12, Route 13, right? So very quickly you can, select multiples and see them directly on the map and make a nice little route map depending on what you want from here. And what's good about this is that the color scheme of all these routes, and generally the colors come in from the GTFS, but you can modify them here. So if these are all new routes or routes that you're going to edit and you want to bring that out, you can change the color just by updating the color right here for all of them, right? So if I want to make them all a specific color, I can do that, no problem. All right, so for our task that we want to do is we want to look at routes that access the downtown station, right? So it's called Rosa Parks Station and sits in the middle of Gainesville. So I'm just going to zoom in and I'll just clear the map. And I'm going to use this route identify. So there are two identifies. This is the GIS identify and this is the route identify. So what I want to do is this is the downtown station area. I'm just going to drag a box around it and say, okay, what are all the routes that access the downtown station? Okay, so a couple things pop up. One is the identify tool. So this actually tells you all the route patterns, right? And you can select one from here, you can flash the stops, you can edit this particular pattern, right? And we'll get to that in a minute, but we want to focus more on this selected list over here that shows us all the routes that are selected. So we can right click on this and we can do this route service report. All right, and this report will basically give us a lot of information about each route that accesses the downtown station. So in total, there are 22 routes, and they have an average of 13.8 hours of service. They have a total of 846 one-way trips that are in and out of the downtown station. An average headway, and if you're not familiar with headway, it's just basically the interval of arrivals. This is the average at the bottom. So each individual route obviously will have its own headway and service levels, but this is a great mechanism for being able to determine what that is. And on down the line, you have a speed, the round trip travel time, the number of vehicles that it would take to operate this route, the percent layover. So on a route basis, what your layover is, hours, revenue hours, miles, the route length, the number of stops that are served, the spacing of the stops, the costs to operate these routes at a route level and then at the total, and then the service hours. So if you want to be able to communicate, hey, we're running from 5:43 a.m. to 10:57 p.m., it's right here in a report for you to look at. Likewise, you can change this so that if you switch to Saturday, you see which routes operate on Saturday, and you also see which routes operate on Sunday. So clearly a drastic drop off in service to the downtown station between weekday versus Sunday. And so just something to note. So we want to focus on this Route 5. We're thinking about adding service to it. And so we want to get to a little more information. So we have this button out to the right, and it says Open Route Service Summary. So we can get to a little more information about it. All right, so if we go from top to bottom, basically some of these are what we had in our existing report, but we get to a little bit more detail. So we go on a time period basis with the peak periods, AM peak, off peak, PM peak, and night. These are all weekday time periods. And then you have your total weekday line, and then Saturday and Sunday. And if you come over to the right, you see that all the numbers are now annualized. So we're taking into consideration the annualization. So this goes back to our operation settings where we're setting the number of days. So all that's calculated into this annual route cost of $1.1 million or $1.19 million. We also see that there's some demographics involved with this. So you have the number of people, jobs, and even a density per acre. You also have the minority population, low income, seniors and minors kind of combined into one. and 1 vehicle or less. So this is a really high number, the 55.5%, and there's probably a reason for that, so we might want to investigate that. So we come down to the bottom, we have a map dropdown, and there are several maps that you can get to. As you can see, there's a route map, population, jobs, land use, and some Title VI maps that you can produce. So we'll open the land use, the route map, and you can see that we have a little more detail in terms of the stops. You have some more detail in terms of the time points along the way. So you can interrogate that map and open it in ArcGIS, etc. You also can get to population, jobs, and land use. So let's go to the minority population. So if we click that, we see our route. This is the route structure here, and we're using a 1/4 mile buffer because the Title VI buffer that we set in the operations settings was a 1/4 mile, so that's what we're using. And it's telling you the distribution of minority population around it, including that it's 18.5% minority along this route. You can switch the variables from here. So we really want to know a little bit more about the population that's enrolled in college. Since this is a college town, we want to select that variable. So this is the distribution, and that 56% of the population is actually enrolled in college along this route. So that's good to know. So that might be a statistic worth noting in the end, right? All right, and of course, all of this is exportable to GeoDatabase, and you can export from here. And I also want to show you the land use part of this. So whenever you open the land use map, it breaks everything down by land use type. So you have residential, commercial, industrial, agricultural, institutional, government, miscellaneous as our default types, and breaks it down in this case by building square footage for each. So you can see that residential makes up 51% of the total building square foot in the market area, and that we can switch this. So I mentioned person trips earlier, the IT trip generation rates. So that's also baked into our market analysis. So each one of these parcels, we can then identify the number of person trips or trip activity that's coming out of each parcel. And that's really good information for, obviously, for transportation planning to know where your major generators are at and what kind of land use they are. So if we want to interrogate this a little bit more, we can actually get into what specific commercial land use types are here. So you have a lot of different options here in terms of stores and trips and commercial space, etc. All that's contained in here. And so you can really interrogate this data and get a good idea of the breakdown of land use within your market for this particular route. All right, so you can also access a schedule. So a schedule is not something that the GTFS provides. It's something that we generate out of the network, and it's basically at time points along the route. So our first trip starts at 6 a.m., the next at 6:20. It goes from Rosa Parks to Publix to Terwilliger Elementary to Oaks Mall, right? So here's the schedule basically, and you can switch to eastbound, and then you're going back from Oaks Mall to Rosa Parks. You can also do it by service day. So here is your Sunday schedule for this route. So just want you to know that that is there. You also have your ridership estimation. So the estimated ridership that TBEST had for this particular route, you can get that detail. You can also edit the service from here. So so what this is are the routes that are serving this particular, the route patterns that are serving this route. And you can get information in terms of span by time of day or TBEST time period. You can have headway, etc. But to actually edit this, you need to go into this, to the route trips, right? So this is a new tool that's just came along in TBEST 4.5, where you actually have a timeline of departures for all of your trips, and these are vehicle trips that we're managing here. So what this allows you to do is interact with the timeline. So if you want to place stops or remove stops or add stops, you can do it all through this timeline and manipulate it as you wish. So in this case, what we want to do is we want to actually change the trips from 6 a.m. to 6 p.m. and we want to make a 20-minute headway, right? So, so what we're going to do is we're going to start right here, and we're going to click and hold and drag to 6 p.m. And we're going to remove those stops, and we're going to start and implement a 20-minute interval. So we've just now generated a new 20-minute interval, and we may want to get rid of this this first trip. So now we have our brand new schedule that we've implemented for this particular route. And so we can implement that for one direction, but we also need it in the other direction. So we're going to save this, and then we're going to use this copy to the service to the clipboard, and we're going to switch to our westbound direction, and we're just going to paste that schedule into this direction. It's going to overwrite what's there. So here's our new schedule. And instead of starting all these trips at 6:11, we're actually going to push this by 20 minutes out. So it starts at 6:31. So it pushes all the trips out to 6:31. So we're basically, you know, we have a brand new schedule now for Route 5, and we can save it, and we can then close this, and all of our information in terms of our summary will be updated. So now our headway is at 20 minutes, our cost will go up. All of this will be reflective of that service change that we've just made in our service editor, right? So that's what general process for editing service and then rolling it up at the route level. And then even rolling it up, if you close this, into this report. So whatever changes we made directly through that will be rolled up into this particular summary. So that now we know, hey, we've modified Route 5, we have an additional number of trips, and this is our new service to the downtown station. All right, so one more quick thing to do is add a route. And I realize there's lots of things that we could talk about, but one of the things that people do very often is just add routes. And we want to just, in this case, add a BRT. And it's going to be a bus. And we're going to call it the campus BRT. And the description will be downtown to campus. And it's going to be an eastbound and westbound route. So if we select eastbound, we get westbound. All right, so we have our new route that's in our list, and we have two patterns, right? And we're going to start out in the westbound direction. So I want to double click on it, and that activates it. And we need to get to our segments list and our stops list. We really haven't looked at these at all, right? So, and what we want to do is we want to place a route from the downtown station out to a supermarket that's out here. So we're going to use a tool, this define shortest path tool, and we're going to start from the downtown station, and we're just going to trace a line, right? So it's going to follow the cursor, and if you notice, it'll follow and take a shortest path to wherever your cursor is. So if it's not the path that you want, you need to set waypoints to define the unique path between waypoints. So now that we've got our turn the way we want it, we're going to go out to the end of the route and double click, and it's going to pick up all the stops that are existing along the route and add them to our route. And we're also going to add a stop at the beginning of the route that's right at the downtown station. So now I've just made all of the stops visible, and I'm going to pop a stop right on top of the Rosa Parks downtown station. So I have that in my definitely added. To do this for the reverse direction, it's the same process, right? So again, we're going to do our shortest path, and we're going to start right here, and we're going to come into the downtown station, and we're just going to double click to end. And again, it's going, oh, it went off track. That's okay. So we're going to add this point. So just like that, we have a brand new BRT route with new stops. If you want to add any stop along the way, all you have to do is add it in. TBEST will know in terms of the sequencing where it's at. So this is the stop before, and this is the stop after our new stop. So then we can quickly add service, right? So if we added pattern service, so we have no service on our new route, all we need to do is say from 6 a.m. to 8 p.m. This is going to be 15-minute service, and we have all of our trips are implemented We just add a speed by time of day to this. So 16, 15, and maybe at night you go up to 17. And you save this and you copy it and place it into the westbound and paste it. Oops, I went too fast on that one. And copy, and then we're going to go and paste those trips, right? And then again, the speeds, and you want to make sure that you're doing directionally the speeds the way they would actually be, because directionally is very important, obviously, in peak periods. So we'll just save this, and then we'll come to our campus BRT, and we'll get to our service summary. So basically, this is going to tell us the population, what's around this particular stop or this route, the service span, the headway, we define 15 minutes, and ultimately the cost, right? So this is the cost that's going to be to implement this particular BRT. And then once we have it, we save the whole scenario, and now we have it, and we can run our forecasting model right here, and obviously that takes a little bit of time, so we're not going to run it through. But what we can do is we can come over, and we already have this campus BRT made, and basically this is what it is. And so we can run the scenario summary tool. So this is a comparison tool where you can get to our campus BRT, which is basically the same scenario, this new route. And it's going to give you a comparative report. So you can see, okay, here is the impact of adding this service, and we have our new campus BRT, and it's going to add an additional 900 riders, is what TBEST is saying in terms of ridership on an average weekday. All right, so really that's the goal, is to get that number, and it's in total it's going to add an additional 1,069 to the system. So it's going to spur some other routes to pick up riders as well, because you're increasing accessibility in the transit network. All right. I think that's it. I had other things to talk about, but of course, you know, if you have any questions, you can contact me. And certainly right now, if we have time for questions, Terry, you can we can field those.
Okay, great. Thanks, Rodney. So let me just jump back here if I can. And as we mentioned, all of the slides that you did see from the presentation today will be made available. And here's the link to the GeoNet, and then again, just the link to the TBEST.org and Rodney and contact information. So, you know, let me, and if you do have questions, please type them into the question box, and we have a few minutes left that we can. Obviously the software itself is, the TBEST model is free. You would generally recommend, though, that an agency that was interested in implementing this would maybe reach out to you, and that you can help them with the configuration, the validation, and even, you know, really some of the training. Is that the typical pattern? Is that what you would say?
Yeah, I would say that, and just really to save, if you're thinking about it, just to save you some time, so that your startup time isn't, you know, wasted, right? So I can do it pretty efficiently. I've done it many times, and certainly can get you started to the point where you're using TBEST rather than configuring it. So that's the most important part, obviously, for the agency to actually get some value and some information out of it.
Okay, there's a, let's see, somebody's asking, are there plans for implementing this in either Pro or integration with ArcGIS Online? And I think you did already mention the ArcGIS Online, but maybe if you can just reiterate that.
Mm-hmm. Yeah, I mean, we're moving towards those options, and obviously the technology is moving in that way, so we just have to move with it. And really this coming year, we're planning on making some larger changes to TBEST, and all of that will kind of come out in terms of what direction we go, whether it's Pro or ArcGIS Online. It's kind of yet to be determined, but certainly we're moving in those directions.
Okay, and somebody's asking sort of the, I guess the constraints, if how important is it if you don't have the parcel information? Can you speak to how critical parcel data is or is not?
Um, well, it's somewhat important in terms of just the ability to look at the distribution of trip activity, and also the Florida model that comes with TBEST is reliant on parcel data. Now, as we go forward, there are other models actually that are that we have calibrated at Service Edge Solutions for various clients that don't have a requirement for parcel data, so that you can run them with just population and employment. So if you'd like to discuss that, we could. But it's definitely advantageous. But the problem is that local parcel data tends to be a little bit difficult to configure, especially if you're going across counties and the variables don't always line up. So there definitely is, when you start talking about parcel data and configuring it, that's a little bit, probably the most amount of time in terms of configuration is getting the parcel data ready.
Okay, and there's a question about the applicability of the model to rural areas.
Yes, definitely rural areas are a consideration, and certainly that's something that people are using it for and have used it for in the past, and certainly in terms of analytics with demographics and trips and all that, it's fine. The model was configured in Tampa, so it was calibrated in Tampa, the current one that's distributed with TBEST, the land use model. So what I would recommend is that you look at ways of manipulating that to more of a rural environment, and so that's something we've looked to in the past, and we could certainly discuss that more. But the applicability would have to be kind of managed and moved to really rural routes where you're talking about riders of less than 20 per day or something like that. Then it becomes kind of a small number, a little bit hard to estimate.
Yeah, okay. And there was a question about the street network that you were using. Is OpenStreetMap an option, I guess was the question? So.
That actually is OpenStreetMap. So we use a service called openrouteservice.org. And so everything that was coming through was actually coming directly from OpenStreetMap into the TBEST environment. So it actually is pulling it down from the web from OpenStreetMap.
Okay, and there's a question about the sort of the land use and the socioeconomic data that you were, particularly they said, how did you get the residential location for the college students?
Well, we don't have individual locations. It's just that is an ACS variable, American Community Survey. So we just implemented that in TBEST, so we're able to use that as part of our market analysis. But as far as the individual locations, I think you could, if you remember in the land use market analysis, you can go to break it down by residential and commercial. We broke it down by commercial, but you could also do residential. And in that, you can see apartment complexes and things like that. So you can assume certain thing about the students, about where they might live in apartment complexes.
So, okay, and we're actually, we've sort of run out of time. Feel free to send your questions to either Rodney or myself, and we'll be happy to answer them. A final point on the data, both Rodney and I have had the conversation that the possibility of also incorporating community analyst data into the model as well, which would then give you, again, some of that employment data by site and some other types of more discriminate data. But we'll stop there. We want to thank all of you for attending today. I hope this was useful to all of you. Again, I've followed the TBEST model over the years. I really think it's probably the best thing on the market, really, for doing that detailed level, service level planning. So anyway, again, thank you all for attending today, and we'll see you the next transit webinar. So thank you. Bye-bye.